Hey everybody, welcome back. In this video, we want to use sets and heaps to solve problem 1647 on LeetCode, minimum deletions to make characters frequencies unique. In this problem, we are given a string s and we want to remove some characters from s so that no two characters in s have the same frequencies. So the definition of frequency here is the number of characters repeated in the given string. So for example, in this string given here, frequency of A is 2 and frequency of B is 1 initially. Since there are only two characters in this string and none of them are having the same frequencies, there is no action required. But in the second example, frequency of A is 3, frequency of B is also 3, and frequency of C is 2. So what we can do is to keep A as it is, but since a frequency of 3 is used, the only action that we have to adjust a string in this problem is to delete a character or delete some letter from the string. So we can drop one of the B's and then, so this is the first time that we're deleting something, and B is gonna have 2 and then accept that. In the next round, since 2 is also used, we have to drop one of the C's from this string, and then since the total number of deletions that we have used is 2, and that is the answer of the solution. First of all, without thinking of how we are going to do that, let's find a way to store the frequencies, calculate the frequencies very quickly, and then use them. So for that, I'm going to use default dict. So using from collections, import default dict, and the frequencies are equal to default dict of type int, so that initially, whenever this is the first time that we are inserting a character into this dictionary, if the key doesn't exist, so it will assign the default value of integer, which is 0, to that value. So for every character in S, the frequency of S, frequency of C plus equal 1. So we are just adding. So now we are having a dictionary, and then now this is the frequency for each letter. As we saw in the second example, we went through the scenario for this one. The only possible action is deletion. So the frequency of characters never grow. We know that. So it is always making lower, or we can always make it smaller by deleting a character, not by adding a character. So with that, if we find a way to sort them by frequencies, sort characters from larger to low, as we saw here, we had frequencies 3, and then 3, and then 2. So if this is the first time that we see a large value frequency, we accept it. Otherwise, if we see a new one, we are always going to the smaller from the larger first. And since we can always make a larger group smaller by deleting them, so the order that we should visit the frequencies is from large to low, not randomly. So since 3 is used, so we removed one of them and then converted to 2 and then accepted since it was not used, and etc. But I don't want to use sorts, but let's sort them for now. The values that we don't have to store the characters at this moment. The only thing matter at this point is the frequencies themselves. So the L, or the list that we want to traverse, is sorted fracted values, and then I want to sort them reverse, so that from large to low. And then for every frequency in L, so we are now moving from high to low. The first one is high, the highest one, and then we are visiting the lowest one. So at the same time, I want to store number of deletions that we do equals to 0. For each frequency, we are moving to the we are iterating on values. we should somehow check if this frequency is used previously in the previous round by larger values. So for that, in order to find the answer for this question query faster, I want to use a set as used is equal to a set. So if frequency, or let's say while frequency is in used, that means this is used, so we have to remove one of them, remove one character. So that would be equal to, we are decreasing the frequency of that set by 1 and then adding that to the number of actions that we have taken. So we continue that until either f is not used, like we saw here, by removing just one character from set B, then the frequency was 2 and we accept it. Otherwise, as soon as it reaches 0, and f greater than 0, whenever it reaches 0, that means no characters left, or that also means we are at some point that we need to remove all of them from them. So for example, if we had A frequency 2 and then B also B1 and then C1, initially we accept A, this is fine. Then B is also accepted, but C we have to delete one of them to 0, and then we don't have to store anything. So, and then that's it. So we have to also, after that, as soon as we jump out of this while, we have to add this new frequency to the use set. So use that add this new frequency, and then we already sort them. And so CNT or counter would be the answer for this problem. Let me try that out. Invalid index. So while f should be while f, oh, there's no keys, while f in used. Okay, so let me submit that. Okay, so that was everything for this problem. Let's evaluate the time performance of this problem as well as the memory complexity for this solution. So as it is mentioned here, all S only contains lowercase English letters. So in ON, we are iterating through S here to build our frequencies. But the size of the frequency that we are storing in the memory is at maximum has 26 keys, since there are 26 characters in English. So we don't have extra or more keys than that. So it is a very small set that also we are sorting the values on 26 elements at max. So these can be considered in O1, or in a constant time. We are building this sorted and also iterating through that. So all of these are O1, and then this part is also O1, or in detail is 26 log 26, which is a constant time again. But the only time consuming part is building these frequencies. But since we are using dictionary, then we can quickly access that and then increase the frequency. And this is also these two parts, only constant memory that we are using in this solution. So our memory is also constant, and our time is ON of the length of the characters in this string. So that was everything for this problem. Hope you enjoyed it.